Hi, this is Titus Kurek. I'm an OpenStack product manager at Canonical, and in this very short video, I will show you how to install OpenStack on Ubuntu in 5 simple steps.
OpenStack is the world's leading open source cloud platform, and its adoption continues to grow every year. Even though it's been with us since 2010, its initial deployment and post-deployment operations have always been a challenge due to the overall complexity of the project. But don't worry about it. In this short video, I will show you how to get a fully functional OpenStack up and running quickly, leaving all its complexity behind. You will only need one physical or virtual machine with the latest Ubuntu LTS installed, static IP address assigned to its primary network interface, 4+ core AMD 64 CPU, 16 GB of RAM, and 50 GB of storage. We are going to use Sunbeam as it provides the most straightforward installation experience for OpenStack ever. Sunbeam is a new project under the Open Infra Foundation's governance created to set the foundation for zero-ops OpenStack. By using highly opinionated architecture and cloud-native principles, Sunbeam delivers distilled OpenStack excellence in a human-friendly format. You can find all information about Sunbeam at microstack.run. Microstack, based on Sunbeam, is an OpenStack flavor designed for small-scale cloud environments, edge deployments, testing and development, with full commercial support available from Canonical. If you want to follow this tutorial in a written form, navigate to ubuntu.com/openstack/tutorials. There are also more tutorials available out there that you can follow to break the ice with OpenStack. That's it for now. Let's get to the terminal screen. The entire installation process starts with installing the OpenStack snap. The OpenStack snap contains the Sunbeam command that we'll further use to bootstrap the cloud and to interact with it post-deployment. Then, we need to generate and run a node preparation script. This script ensures that the machine has all the required software dependencies installed and is configured correctly for use with Sunbeam. Finally, we need to bootstrap the cloud so that its control plane, data plane, databases, and other components get installed and configured accordingly. Depending on your machine and network connection, this process may take up to 1 hour. In the meantime, we're going to have a closer look at the architecture of Sunbeam to learn what exactly to expect once the Sunbeam cluster bootstrap command finishes to execute. Sunbeam uses snaps as a primary mechanism to install corresponding OpenStack services. This includes typical data plane services such as QEMU, libvirt, NovaCompute, OpenVSwitch, and OVN chases. Those are packaged together inside of the OpenStack hypervisor snap that gets installed directly on the underlying machine. In turn, OpenStack control plane services run as containers on top of MicroK8s, a lightweight Kubernetes, that also gets installed as a standalone snap. Finally, the last class of services, cloud management and governance services, also come in the form of snaps. While the OpenStack snap is a kind of a wrapper, providing an interface for bootstrapping and interacting with the cloud, the Juju snap provides all the required operator orchestration capabilities. Both data plane and control plane services are wrapped with charmed operators for operations automation purposes. What makes Sunbeam different from other leading OpenStack delivery tools, such as Kola Ansible, is its cloud-native architecture. While Kola Ansible uses Docker underneath, Sunbeam uses Kubernetes. This allows leveraging native Kubernetes capabilities, such as stateful sets, for example, for high availability modeling. Furthermore, while Kola Ansible uses Ansible to install and manage OpenStack services, Sunbeam uses charmed operators instead. This enables packaging OpenStack operations code in the form of software extensions and reusing them across various organizations, industries, environments, and clouds. If we go back to the terminal, we can see that Sunbeam has already installed all the necessary snaps. We can also take a look at our Juju environment by listing all available controllers, models, and the status of the current model. As you can see, Juju has already deployed all the necessary OpenStack control plane services on MicroK8s using charmed operators. This is how it looks from the Kubernetes point of view. If we list all available namespaces, we are going to see an OpenStack namespace that was created by Juju. We can then list all pods running in this namespace. Here we are going to see one pod created per each of the OpenStack control plane services being used. Finally, we can display pod details to see all the containers running in a pod. As we can see, each pod consists of 2 containers. One of them is used to run the service itself, while the other one is used to run its operator. Getting back to our primary terminal window, we can now see that the Sunbeam cluster bootstrap command has finished successfully. At this point, our OpenStack cloud is up and running. We can now use the OpenStack client to execute sample OpenStack commands. However, to be able to demonstrate typical OpenStack capabilities quickly, we need to configure the cloud so that sample records like tenants and images would be created. In order to configure the cloud, execute the following command. At this point, we shall be able to launch our first instance. Sunbeam ships with the launch command that can be used for demonstrational purposes. Once the command finishes executing, you should be able to find all the necessary SSH details in the command output. You can use them to connect to the instance. And here we go! We are now connected to our newly launched OpenStack instance. We can use typical bash commands inside of it. For example, we can check its uptime. To disconnect from the instance, type exit. Apart from the OpenStack client, we can also use the OpenStack dashboard to interact with the OpenStack cloud. In order to obtain the URL of the dashboard, type the following command. Then, open your browser and go to this URL. You will see an OpenStack login screen. We can obtain the password of the demo user that we created previously in the Configure step by taking a look into the demo-openrc file. Type demo as username, the password provided, and users as domain name, and press the sign in button. This will open an OpenStack dashboard landing page. Now if you navigate to Projects, Compute, Instances, you shall be able to see the instance that we've just launched. And that's pretty much all for today. I would like to thank you very much for your attention. I hope that this quick tutorial helped you to break the ice with OpenStack. You can now follow other tutorials that are available for you at ubuntu.com/openstack/tutorials to learn more about the world's leading open source cloud platform and master it. If you have any questions, don't hesitate to reach out to us for community help. You can find us at discourse.charmhub.io. If you found a bug in Sunbeam, please report it at pax.launchpad.net/snap-openstack. Sunbeam is a quickly evolving project and your feedback is very much appreciated. One more time, thank you very much for watching this video. Looking forward to meeting you at the closest possible occasion. Bye!